The next step is going to be to hit the internet and find a dipole calculator. I have one bookmarked. As I said, I'm going to be making a 10 meter dipole, but this can be used to make any size dipole that you want to make. I don't recommend using it for any frequency that is higher than, you wouldn't want to make anything higher than 440 megahertz with this, so you wouldn't want to use this for 900 megahertz, you wouldn't want to use this for 2.4 gigahertz, you really would not want to use this setup for Wi-Fi or anything even remotely close to it. But I'm an amateur radio operator, and I have my technician license, and the technician license with amateur radio in the United States gives the operator access to something that's called the 10 meter band, which the section of it that I'm interested in is from 28.3 megahertz to 28.5 megahertz. So I'm going to make this dipole for 28.4 megahertz, which is right in the middle, and this is going to then let me use the new HF radio that I bought or bartered for. Didn't buy it, I bartered. Amateur radio, we barter everything. But this will let you use that, and this will make a nice base, and in the event that I want to use a frequency higher than 2.4 gigahertz, it's very, very easy, if I want to use a frequency where the wavelength is longer than 10 meter or longer than 2 meter or something like that, whatever the wavelength is, if I want to use a new frequency, all I have to do is go out, buy some wire or pull some wire out of the back or wherever I need to get wire long enough to make the dipole, strip it, make sure it's heavy enough gauge for the dipole I'm making, and then attach it to this. All we're actually going to do is take the wire, slide it underneath the hose clamp, and just tie these two together by just squeezing them together. That's how the electrical connection is made for this. And this is actually an antenna I learned to make from my local amateur radio club. We actually made one. They had a base already made, but they added wire to it to make a dipole to use on field day this year. If you are into amateur radio and you don't know what field day is, I would suggest that you go find out. Field day is a great event. If you are not into amateur radio, I would suggest that you go find a local amateur radio club and look into field day. They'll be having one next year. Amateur radio is a great hobby to get into, and it lets you play with cool stuff like this legally. Well, you can play with cool stuff like this legally anyway, but I'm going to actually use it to transmit a powerful radio signal, and that's not always legal. So I'm going to go ahead and pop over to the internet, find out the length that I need for my dipole. I can tell you as a rule of thumb, this is 10 meter. Your dipole is going to be half of your wavelength. The wavelength in this case is approximately 10 meters. So you take that, cut it in half, that's approximately 5 meters. 5 meters converted to feet is approximately 15, 16 feet. So I'm looking at about 16 feet total for both cables, the cable going this way and the cable going this way. So I need to make two about 8-foot cables or so for the band that I'm interested in. But I'm going to go find out what the exact lengths are. So I'm going to hit an online calculator that I have bookmarked, and we'll check that out. Okay, here's an online calculator for the Kitchener-Waterloo Amateur Radio Club, and I have put in the frequency that I am interested in, which in this case is 28.4 megahertz. I've already hit the calculate button. It has already given me answers, and I need to make two about 8-foot 3-inch legs for each side of the dipole. So you can see here, this is for the 10 meter band. Remember, a dipole is about half of the wavelength. Well, a dipole is half of the wavelength. In this case, about 10 meters becomes about 5 meters. About 5 meters is right at about 16.5 feet. And then half of that for each leg of the dipole is 8.25 feet. So that's what I'm going to be shooting for. I will post a link to this on the show notes, but to be honest, I found it as the first hit whenever I used Google and searched for dipole calculator. Okay, I'm not actually going to finish the dipole tonight. This is the wire that I'm going to end up using for the dipole, but I'm not going to finish it tonight. But what I am going to do instead is show you with this piece of scrap wire that I've got just exactly how you would connect it into the system here. So all you have to do is get your scrap wire out of the way, take and back off the hose clamps or one of the hose clamps. In this case, I'm going to back off the one that's tying to the shield. Take one leg of your dipole that you have measured. Keep in mind that you have about an inch or however long from the hose clamp to the middle here. So cut it to length, keeping that in mind. Then take your hose clamp, loosen it up. Okay, I've got it loose. Slide these under together. Put them together like this. And then tighten your hose clamp back down. The antenna makes electrical connection through the hose clamp and the copper. And once you get your hose clamp tightened back down, like so, have a nice connection there. Then you just take this, run this out, and there is one leg of the dipole on your brand new homemade dipole base for amateur radio, or you can use it for CB or whatever you want to do. Again, I pretty well am of the opinion that this should not be used for any frequency higher than 440 megahertz, 440 megahertz. Actually, probably any frequency higher than about 150 megahertz is too much for this particular design. But where your frequency is less than that, this is a great base type to use to make your dipole. And the best part about those frequencies is they are somewhat forgiving on this. So I'm going to go ahead and end this segment for now, because you can see how to actually make your base. All you need are a piece of PVC, a couple of hose clamps, some coax cable, some zip ties, and your coax cable. It is nice if your coax cable has already been crimped with the end that you're going to use. In my case, it's PL259. That's your most common end that you use, anything amateur radio related. And that is the show. That is the antenna. And don't worry about these legs. They probably won't actually cause you enough interference for you to worry about removing them. If you really are worried about it, cut them back so they're not over the top of the antenna, but don't cut them all the way back, because remember, you have to loosen the hose clamp to put your dipole element on and then tighten it back down. So that is this segment, and I am the Ophidian. Thank you.